The most important word. Ooh, this is good. The most important word in section 5.1.
Try. Something.
That's good for 5.2. I mean, it's good for 5.2. But it's good, but for 5.2. The most important word
Verify.
for 5.1. Huh?
Verify.
That's 5.2.
Oh.
You guys are doing good for 5.1.
Factor.
5.1.
Simplify.
Factor was in there. Simplify. For 5.1, like you're supposed to do stuff and simplify. You're just playing with expressions, being like, what can I do? How can I change it? That was 5.1. We're going to bring in the word evaluate also. We did that a little bit yesterday. That's kind of the 5.1 skills. Now 5.2 is the word verify, which underneath verify, don't give up, right? Even if you try something, even if you make a mistake, or even if you go a dead-end way, okay, you learned something, don't keep going that way. Come back and try again. Try something's underneath here. We're in the office trying to get copied out. I'm guessing like 5 or fewer still in the back. Good question. 5.2 is T-proofs. 5.3, what's the most important word? Not really. Kind of like down here-ish. Solve. Okay, so we have simplify, we have verify, and we have solve. Okay, there might be some other words that come in, but those are the 3 most important words that we had already talked about in chapter 5 with the most basic, fundamental trig identities. But in 5.4, we just started this yesterday. We technically don't have this homework due until when? Friday. But tomorrow, we're not going to spend the whole class still in this section. But come tomorrow with homework questions you get stuck in. Okay? Because in 5.4, 5.5, you need to get into it and you need to get stuck and then brilliantly work on it together before the day is due. Does that kind of make sense? Okay. But 5.4, help explain to Claire why do we have like these little notes on the side that don't have anything to do with the math and they're just
ways to remember things. Yeah.
Why are we remembering things?
Because they're like flipped around. Some of them are items.
Oh, because
we have a formula portion for test notes. So, actually, guys, this might be helpful since we didn't actually look at it yesterday. Can we peek at our calendar real fast? Maybe. I'm just gonna go for it. P.S. I'm showing calculus kids, my AB and BC kids, an online tutor that has come up in the last couple years, and he's good for basically everything college STEM. The physics kids are really enjoying him. Khan Academy is one, and he is helpful and he is good. So is there's another tutor for a lot of math, like college math, linear algebra, calculus, etc., called Patrick JMT. He uses a whiteboard, which I think is super helpful. He's good, but there's a new guy, the organic chemistry tutor. He's a good one. Just kind of throwing that name out there if you guys take physics or if you ever get stuck in chem. Or actually, he's really good for calculus. He might have some pre-cal stuff too. He's a little dry, I guess you could say. He has a little bit of a lisp, which can be kind of a little distracting sometimes. But he has really good explanations, and he reminds you of all the stuff you need to know before. Anyway, just throwing it out there because more and more as you guys continue on in your education, you have to become more and more independent. But that independence is going to be dangerous if you become lazier and lazier and steal stuff from other people to try to get what you want or get what you need. But if you can actually use these really cool resources like all these online tutors, some of them free, some of them you have to pay for. But this guy, he has all of his videos just on YouTube. Just trying to show you there are some people out there that are trying to make these really difficult subjects understandable, and they have really good explanations. Anyway, all that to say, he might be helpful in pre-cal, he might not. I haven't really dug into pre-cal. He is really helpful in calculus, so I was just having that tab open. Honors pre-cal. But yeah, you're right, Alec. Patrick JMT can be really helpful too. Just for most of us, if we have a question on a homework problem, most of us don't really want to go actually learn the topic better. We really just want an answer to our question. That's dangerous. I mean, it's understandable in this super fast-paced society, but it's dangerous. The most important thing is having a better handle on the content, but I realize time is short, you're stuck, no one can help you. So these tutors that are online, they don't necessarily answer your homework question. Wait, but the online tutor that's there. Has anybody used him yet? Or them yet? This year? No?
Not use later.
You guys realize like there's online for our textbook tutors that are just there to answer questions up until midnight every night during the school year.
Did they take off during winter break?
Probably. I think they're only like, well, you're right, they might be off this week because of LAU's. Well, I don't know what system they use, like what their specific starting day is, but they usually have like little announcements like, hey, the tutors will be back here and then this and that and the other. But yeah, they're online every day after school. I've only had a few kids ever use them before, which I thought was kind of interesting. So I'm like, if you want someone to answer your question, go ask the person who has your textbook and is there to answer it. But anyway, if anyone ever uses them, let me know how helpful they are. But coming back, in your calendar, we have a test on Tuesday.
Noble Part 1.
With Monday being the formulas. Yeah. With Monday being the formulas. So even though our 5.4 isn't due until Friday, remember I said we're starting 5.5 here, and basically if I were you, you write down all the formulas now. Just get down all the formulas on a formula sheet. Remember, you can be using the formulas in all of your homework problems. You don't have to just remember them when you're doing problems. So I would write them all out. It's a good study sheet to use above and beyond like a Quizlet or a flashcards. If you write them all out, you can be using them for your test review. You can be using them for your homework problems. You can be using them for in class, having it out and making sure that you're tracking with what we're doing. Because I'm pulling things off the top of my head because I have them memorized so well, but you guys don't have to when you do problems. You're allowed to have them in front of you because that's what it's going to be on the day of the test, right? And I make them so that way it's fair. Everyone has the exact same formula page, but you can definitely make your own to be using this entire next week. And depending on how things go, it might get budged to Wednesday, but remember we're already behind, so we kind of just lost a whole week. See what I mean? So we'll do the best we can to have it, the problem portion, be on Tuesday. Not pushing you guys, but just getting it done. Problem portion here, formula portion here. I will get down all the formulas tonight. And then I showed regular pre-cal because they're just doing section 5.1. So I'm just showing them what's coming for them because it's very similar to you in that formulas one day, problems the next. They're just not going to be there for another couple weeks. You guys know at the end of your chapter there's that like review part, right? You can find all your formulas right here. 5.1 formulas, 5.4 formulas, 5.5 formulas. You can just copy them down. Is that cool? Or just open your book and use it there. Alright, sorry, just making sure we're all on the same page, getting Claire caught up, and then Emily, if she's watching the video, or if she does, she probably won't, but making sure she knows what's going on too. So anyway, long story short, I gave some ways yesterday to try to remember, like sine, cosine, with or together, cosine, sine, cosine, sine. Sine, the signs stay the same, so a plus is with a plus, a minus is with a minus, but then after we talked about that, then we just did a few sample problems that are not really simplify, verify, or solve. It was instead trying just to kind of develop the idea and be like, what are these guys for? Well, they're because, not solely because, but to illustrate what they're for is, what if you were to want any of the trig of 11 pi over 12? It's impossible. It's not in the unit circle until you realize 12 could come from denominators of 4 or 6 or 3 that are in the unit circle. And so if we can take an angle, and if we could break it down into unit circle values, okay, well, how would you do this? Great, they're unit circle, but how do I, distribute the sin, spread sin everywhere. That's a great idea, said no one ever. Because sin doesn't distribute. Well, sin does. Sign shouldn't, right? Can I just bring the sign and boop, boop? We saw that yesterday, because does the subtraction, does the sign of that angle equal the same thing as the distributed sign? No. So these are not equivalent, so I cannot, if I see a trig function of some sort of composite argument, some sort of operation going on, I can't just treat this like times, because it's not sign times, it's sign of, right? So the only legal way to proceed was to go ahead and go get that formula from this section. Do you guys have them in front of you so you don't have to just remember them? How do you do sine of u plus v?
Sine u cosine v plus cosine sine v.
Got it. See? So that's what I did. I did sine of u cosine of v plus cosine of u sine of v. Or sine, cosine, sine stay the same, cosine, sine. And I, in remembering it, just for the memorization portion of the formulas, sine is not not with or together. Okay, fine, not together. Sine, then cosine, not sine, sine. Sine, then cosine, cosine, sine. That's just how to remember. But remember, keep those formulas in front of you. You don't have to be recalling them right now. So this showed or reminded us, you can't just distribute trig. It doesn't work that way. It's not times. There are all these fundamental identities that are letting us proceed forward, but it's not with the nice, easy, simple distribution. So the rest of the class, guys, we're just going to practice. Some of these are going to look weird because basically those easy formulas in section 5.1 didn't need as much practice because they weren't quite as weird and out there, like they weren't quite as complicated. So some of these aren't going to look exactly like the beginning of chapter 5, but then some are. Just with the new formulas in your pocket or in your notes or now that we can access. So, number 39 is not really a 5-1 or 5-2 or 5-3. What's he telling us to do? Okay, hold on. Mr. Graff is just trying to get his kids talking. Do you guys hear yesterday what he did with all of his algebra 2 and his geometry kids? Yeah. Okay. I don't know. There are all these little phrases now. They're going to be cool and chanting and all that fun stuff. We don't need to chant. Okay, we're honest. It's all right. We can be a little bit more above. I shouldn't say above. A little more advanced, a little more academic, a little more like a college classroom. You could ask Maggie how Berkeley is. I'm not sure. Are your teachers throwing things out in Berkeley and having the whole class chant and do fun back and forth? Okay, exactly. So we can act more like a college class. But we can say, if I say, okay, what are we supposed to do? If you're totally stuck, what can you always do? Yeah. So Izzy, what do the directions say? Perfect. So if I just randomly say all right, cool, just read the directions, I'm just getting us started. Does that make sense? Because we're quiet and we're just not talking. So Izzy just said find the exact value, and Jaden, you're thinking something. What are you thinking?
So that one matches the tan, u minus b.
Okay. Pause. If he hadn't said that, if it didn't match one of the formulas that we could maybe do another way, what's the only way forward?
Calculator stuff.
Okay.
Using the...
If we were allowed to approximate and do decimals, yeah, throw it in your calculator. But if we were trying to do it how it said, which is exact, which means absolutely no decimals, you got to have nice little radians and square roots in there. Unit circle, unit circle, unit circle, unit circle. Let's do a lot of that.
No.
That would be the only way forward. But one more time. Jaden, you just noticed that this is what?
The tan parentheses u minus b.
Yes, true.
Why is it always your class that it hates me?
What?
Let's just,
Oh,
let's
okay.
pray about it.
Let's just not.
Pretty close number. You guys realize that I could be throwing up prayers to Jesus about my smart board without stopping class, right? You can do that too.
What?
Life is hard. You can just throw up a prayer.
Oh. Yeah.
Just the idea of you don't have to actually make a formal let's all pray. That's good too. But you can also just be Jesus, help. Anyway, yes, he helped, or it just worked out. But either way, he's good and in control. There's a formula. Except, isn't this backwards?
Yeah.
We can use formulas backwards?
Yes.
Yeah.
Combine that.
Tangent of theta is sine over cosine. Sine of theta over cosine theta. But sine over cosine, sine of theta over cosine of theta is tangent of theta. We can use it either way. So, yes, we can memorize this goes here, but if you have the formulas in front of you, would you notice that you could go backwards? I'm just plugging in, Laurel. Go ahead. What's up, Kim? If it'll help, are you still with me? I don't know. Why is this good?
That's at the top.
Because there's two U's and there's two V's. They're both the same.
Yeah, so I figured a U and a V, right? So I put the U in the U spot and the V in the V spot. But why is it awesome that Jaden made that connection? It's going to make our life so much easier, Priyanka. How fun would it have been to do that? Gross. How long is it going to take us to do that? Right? And they're the same thing. So to solve him, why don't I just do that? Sweet. So these formulas can be nice in our homework because if we see a nasty expression, if we can jump to, oh, that's easy. That's just sine of u minus v. And, well, basically, as long as this is a unit circle after I subtract not an 11 pi over 12, I'd be in trouble after this addition. But if it's unit circle, I don't have to do all that mess. So what's 5 pi over 6 minus pi over 6?
2/3.
Good, because you already did 4 pi over 6 and you reduced. Are we okay?
Yes.
Is that unit circle?
Yes.
I just have to do one thing instead of 1, 2, 3, 4, and a lot of math. So how do we do tangent of 2 pi over 3? Pause, thank Jesus that we can do this and not have to do that. And then take the time to do the work.
2/3.
What am I doing? Cheater chart. Tangent. Tangent of the pi over 3, dude. But what sign is it going to be? A negative or a positive? Why negative?
Because it's in the second quadrant.
You see it? It's going to be this dude, and this dude is all students, not tangent. Dun, 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 dun. We could have gone piece by piece by piece by piece and subtracted and multiplied in complex fraction. Ugh. We could have done it this way, but since it lined up with one of my formulas, and since the subtraction is a unit circle, I don't have to do it the long, hard way. 2 pi over 3 is unit circle. So, remember, these formulas, you can look either direction. Another important reason to have them in front of you, because this is not obviously a formula, unless you look at it and say, oh, it's the other side. And my life just got easier. Does that kind of make sense? So when you're looking at these formulas, go either direction, totally fine. Oh, okay, well this one's obviously...
You just gotta plug it in.
Oh, plug what in?
The u and the v, and then you just put it in the big equation.
It's a great idea, Alec, but do you see what you've been given? You're exactly right if we knew what u was.
But this is, oh, the sine u.
Right? That's the struggle. If you are a highlighting kind of person for a test, highlight this problem, because kids get stuck on this the day of the test, after we've done homework, after we've talked about how it's tricky, after we've done it on review.
Since it's numbers like over each other, you could find the odd one out or whatever.
Because these numbers represent what? Why is he saying there's an odd one out? Who's the odd one out?
Like it's like hypotenuse and adjacent and opposite.
Jaden, that's big brain.
He's seeing that these are ratios, and ratios represent sides, and sides can be found with Pythagorean theorem.
And what happened to the fraction?
Now, did you see this was a triangle?
Mm-hmm.
Jaden did.
I understand what happened to the denominator. What? I'm confused.
Okay. What have I done?
Oh, yeah.
Jaden said, these are hypotenuses, and from that, I'm like, oh, he realizes SOHCAHTOA. This is an opposite, this is a hypotenuse. SOHCAHTOA, this is an adjacent, this is a hypotenuse. Why do I have two different triangles?
Because each one is a different angle.
Two different angles, my U and my V. Why am I not just plugging in U and V? Well, I don't know them. Use sine inverse, you can find it. But 5 over 13 is not in my unit circle. Well, it's fine, we have a calculator. Okay, the exact word, no calculators. Okay.
Sorry.
I'm just explaining. Because I understand, I understand. If you were in like a physics class, you would definitely be going to calculators and finding decimals and using it, just trying to get to the answer. But we're trying to instead understand the idea. And do as much with geometry as possible. So Alec had a great idea. Who's U? Who's V? Plug it in. The problem is, do we know U's angle measure? No. Do we know V's angle measure? No. All we know is its sine ratio, opposite hypotenuse, and its cosine ratio, adjacent hypotenuse. So I can't go plugging in U and V. But what could I do if I use the formula? You have the formulas, right? And if you're trying to memorize at the same time, co is with or together, hence why. You guys looking at it? It's co-co, right? And sine. It's the with or together one, except cosine, the signs change. Now, problems. I'm just reminding you of how to study. But I'm just needing my cosine U, cosine B, sine U, sine B. That plus should be over there. How did this make everything possible where a second ago it was impossible?
We use
We used
the formula.
the formula, but how am I allowed to go forward now where I wasn't allowed to go forward here?
We have.
I can solve for the cosine of the U.
Well, don't you have to do Pythagorean now?
Okay, yeah. But we can solve for the adjacent to make the adjacent over the hypotenuse to plug in for the cosine of. This just, here, I was like, who's U, who's V? I don't know. I don't have one triangle to find a cosine. But if I'm able to split it up with my formula, I have a triangle for him, go. I have a triangle for him, go. I have a triangle for him, go. I can find them individually where I couldn't find them combined a second ago. That kind of makes sense?
So, cos U is 12 over 13.
Yeah, because Pythagorean says, oh, that guy's 12. Yeah? And Pythagorean also, just because we're going to use it, says this guy is
4.
Okay, and I did that fast because they're special Pythagorean triples, right? 169 minus 25 is 144. That gets me 12. Or 25 minus 9 is 16. That gets me 4. Like, you can plug in a squared plus b squared is c squared. If I end up with 12 over 13, whose cosine of v?
Negative 3 over 5.
Oh, they already gave us that. Sweet. Plus?
Sine U is 5 over 13.
Bounce back and forth.
Sine B, so
You see it?
yeah.
Now here's where most kids make mistakes, and you might want to highlight it, you might want to make a note. The substitution, when you substitute, all the trig is gone. The trig is right here. The fractions are the trig. One mistake, because on the test you're allowed to have a calculator for some of like the weird ones. A lot of people love to put in the cosine of 12 over 13. What? That makes no sense. 12 over 13 is the cosine. Some people love to keep the trig around when they're supposed to be gone because we plugged in and substituted them away. And that's the whole point. Now it's possible. Even better yet, they both have common denominators because they had the same hypotenuses. Hypotenuse? Anyway. 65 is the common denominator. And I have negative 36. PEMDAS says multiply first before adding. So what's the final cosine if I was able to figure out these angle measures, subtract the two, make a new triangle, do the adjacent over hypotenuse, I would get negative 16. And I never had to go to my calculator to figure out those weird random angles with those ratios anyway.
So, for when you have the whole thing, just get the common denominator and add them?
Well, technically, Alec, we could have just like multiplied then. I just was saving time.
Okay.
But yeah. So the most common mistake is not realizing these go to triangles or could tell us stuff about triangles. Forgetting to go to the formula, and then when you do substitute in the information, keeping the trig. Those are the 3 mistakes I see over and over again, year after year. And you guys will practice in homework tonight and see how it goes. And if you make those mistakes, it's okay. You'll catch yourself in homework. You'll grade it in a colored pen, hopefully. And that way you can study it before the test. But I just told you that's basically a test question, yeah? Cool. Ooh. What are the directions all the time, every time? Directions give us... Interesting. Directions give us a direction, if you understand them, right? Directions tell us what to do, direct us as to what to do, but they also give us a direction to head. Anyway, proof should be connecting in your brain, hopefully, with what section?
5.2.
5.2.
Oh.
Wait, but the nice thing is, if it's just a T-proof, all I have to do is show that one side is the other. Do we actually have to go finding theta?
No.
Unit circles? No, we just need to show one side is the other. Does that make sense? KJ, hang in there, bud. What side do you guys want to start on? The left side or the right side?
The right side.
Your other right.
So-
Start with, no. The
You're allowed to have your formulas in front of you.
Yay.
Wait. Why? Cosine of u minus v, sine of u plus v. I get it. We have to plug in all these formulas to both. You could. Why was I hinting you should go look at formulas? Not just the new ones, but also the old ones.
Those are things we call them.
Cofunction. Section 5.1.
Quick.
Cofunction. Sine of. Uh-oh. Is it pi over 2 minus or pi over 2 plus?
It's pi over 2 minus.
Alright. Well, it was a good idea if it matched up. But is it the actual cofunction ones?
No.
Bummer. Okay, if it was a minus, we just go use the cofunction and forget that. But it's a plus. It doesn't match. Oh! Just distribute the sin, right?
Can't distribute.
No.
Can't distribute or shouldn't distribute. Can't distribute the sign. Okay, so. Don't we have this one written right here, ready for us to go?
Yeah.
So how do we break this up? The only legal way? No. Is using my formula. So, cosine of u, with or together. Signs change. Once again, you're allowed to use your formulas. I'm just reminding how to memorize. Plus.
Is it sine pi or sine pi over 2?
Wait, wouldn't it be?
I've just done this one. No.
Oh. Okay. Wait.
This is
Okay.
You see it? Now, sometimes in homework, it's going to start to be like, I do not have enough room because that's this huge thing and that's this huge thing. That's fine. You can just set up like a little, well, I'm just going to go down here and keep at it. But now, Jaden, now it's his turn, which he has his own formula of sine, cosine. So sine of the first, cosine of the second. Sine, the signs stay the same. Cosine of the first. This is supposed to be 0?
Oh, wait, no, that's minus.
Worst comes to worst on the test, you at least have gotten a couple points, right? Just
Yeah,
write a
just
0 and say, I don't know. But wouldn't it be nice if we could fill in y and get all the points?
We can cancel out some stuff.
Oh, doesn't? Nope. Pi over 2, like sine of pi over 2.
Aren't those unit circle things?
They-
Isn't he somebody I should be able to find?
Yes.
Isn't he somebody? And isn't he somebody?
Maybe.
He? Why are they all he's? I don't know, sorry. I'm not
Maybe
sure
gender
girls will be
equality.
offended by not being called
Is
trig
it,
functions.
is it
but-
she something?
Well, you can choose these days. It's all good.
Okay, that was actually funny. Well done. Okay, coming back. So you have pi over 2 and we have pi. Or maybe you're using the cheater chart. A lot of you use this cheater chart. Okay, so good job. I know we have our 1, 2, 3, 3, 2, 1 all over. Okay. Those are not these guys, right?
No.
Those guys are the ends. True?
Yes.
So before the 1, 2, 3 is the 0 and the 1. Yeah?
Yes.
And before the 3, 2, 1 is the 1 and then the 0. Whew, and I don't even have to worry about tangent. He's not even up there. Okay, so this guy, oh, hey, that's 1. This guy, oh, hey, that's 0. And then we'll figure out those in a second, because isn't pi like this guy, but just flipped over there? So I have my 1, 0, my 0, 1 if your brain does this instead. I'm not sure exactly which way your brain goes, but sine is 1 at pi over 2, cosine is 0. Or if you're one of those ones that does pretty well knowing what sine looks like and what cosine looks like, remember, 2 pi, pi over 2. Sine is 1, pi over 2. Cosine is 0. Excuse me, is 0. Well, you got that. Sine is 1. Uh-oh. That's the second part. Sine is 1. Cosine is 0. Oh wait, 0. Doesn't that just go away?
Yes.
Oh, get that.
Destroy them.
But we still need to do pi. So for pi, cosine is -1. And for pi, sine is 0. Oh wait, 0. That goes away.
They cancel.
Cancel those.
Negative and the positive is 0. Now I've shown it, and I only needed to do one more thing.
That's cool.
Ring.
But why did we go unit circle? Because some of them had angles. You see it?
Mm-hmm.
Once we legally did our formulas, we couldn't do that distribution thing up there, but we are allowed to come down here and say, oh, I know you and you and you and you and you. Now, PEMDAS stuck these together, so I had to keep them separate until I got my quantities, and then I had like terms to combine. But there we go.
Where'd you put it on both sides?
Oh, it was our formatting for section 5.2 that we would draw the T, we would rewrite one side, and we have to stick to him and play with him without moving anything back and forth until we make it match. And so once we make it match, it's just the format of saying, hey, look, I got it.
But for like this, the cosine pi 2, like that's like one side.
Oh, yeah, it
That's-
technically is supposed to be up
Oh.
here. I just ran out of room.
Okay.
Yeah, so I wrote him first, and then plus, and then I went to go do his formula, and I was like, forget it. And I just good. Are we good? Ooh, directions have changed, right guys?
Find all solutions.
Find all solutions. Give me a section.
69.
That's the problem number. Good. Give me a section that we can think about these directions.
Nice.
5-1, 5-2.
Uh,
5-3 because we're solving. 5-3 because we're solving, which means we're trying to think unit circle. Let me do something like negative pi to 2 pi. Are we able just to do a T-proof and say, you always
No.
match? No. This one was a always true. This one is a sometimes go figure out when. My final answer should look like unit circle values. So how do we get there? Factor. No. Play. Gotta change him.
Wait, what about the sine x plus pi?
Good.
So you can do that with sine.
Section
u plus
5.4. Good. Has sine of, sine is not with or together. Oh, don't worry, you're allowed to look at your formula. I'm just never.
sine u cos v plus cos u.
Sine stays the same. Good. Why is Jaden doing that? Well, I need to solve this, and right now it's too messy because I don't know how to find the zeros. But if I'm able to change something, hey, there's a formula. Now, guys, in all of these problems, do you think maybe like some quotient properties might come back, or some Pythagoreans might come back, or some old stuff might come back? Yeah. We just have new things as well. Does that make sense? Now what? Nothing matches.
Wait. That
Are
would
those
be.
unit circle, guys?
Yes.
Sweet.
Cosine is
-1.
-1 sine.
If you're visual, remember cosine of pi. Remember, he's -1, whereas sine of pi is back at 0. If that helps.
Oh.
Oh, hey, anything
Yeah.
times 0.
0. Get rid of the ones, dude.
But here's the problem. PEMDAS has these tied
Kill.
together because it's a times. You see it? You kill PEMDAS.
But it equals 0 still because they cancel each other out.
Be careful. A negative sign and a negative sign.
And
-1 minus 1 is -2. See it?
Oh.
Oh, you have to distribute the negative.
-1 plus -1. Remember, any subtraction is always addition of the opposite. -1 plus -1 is -2. But now, guys, you see how it's so much better, because can't I just get sine alone by subtracting and dividing? So now I have sine of x is equal to -1, -1 divided by -2 is a positive 1/2, right? And I'm coming back here and asking, what angles am I looking for? Well, I'm looking for any angles that are in that 0 to -pi, but also in that 0 to 2 pi range. Just thinking about the entire rotation I'm allowed to look at. I'm allowed to look at negative pi or positive 2 pi. Okay. Sine is 1/2. 1, 2, 3. Oh, 1. What angle is that for sine?
1.
Yeah, it comes up right away. Who's
Pi
that
over
right
2.
away?
Wait. Negative pi over 2.
No, careful. In our cheater chart, remember, for sine, pi over 2 is the last one. If 1 is coming up right away, it's good. It's that first pi over 6.
Oh, bruh.
Sorry, pi over 4, pi over 3. Yeah, it's that pi over 6 guy, not him. So I have pi over 6, that's one location. Bianca, I saw you, I'm coming.
No, it's okay.
Pi over 6 is my one location. And where else is sine positive? All students, right? Go pi over 6 back. What angle is this going to be if it's pi over 6 away from pi? 5 pi over 6. 6 take away 1. Oh, hey, and this is illegal. Like, that's not going to get me any answers because sine is positive up here. Well, that's it. I have this guy and this guy, and none of those, and then none of those. Okay, did I zoom past someone's question or anyone else's question?
I don't understand. The integral of negative pi to positive 2 pi
Will be, intervals will be given to you. I left them blank in examples so I could just do whatever feels right in the moment, so I just made that up for us to have them.
I know, but I don't understand what's in that integral. Like, which way does it go?
What I do whenever I have an interval of angles is I always start with what I know, which is 0. In physics, they kind of have this thing called like the right hand rule to where you're always pointed a certain direction. Because in the real world, like, where's my x and y axis in the sky? Like, you just kind of make ones wherever you are. But for me, I make my 0 my starting point, but then think 0 is in between, right? So I think 0 to 2 pi, that's part of this. 0 to 2 pi. All of the angles in one rotation of the unit circle. But then I also have to think about, are there any angles going to negative pi? Remember, that's the other direction. So this was just showing, hey, are there any places in the third or fourth quadrant rotating the negative way? Or are there any places rotating the positive way in the entire 4 quadrants? So there's my 0 to negative pi and my 0 to 2 pi. Put them together, that's where I'm looking.
Okay, so it's only those two.
Yeah.
So I'm good all the way up until sine x equals 1/2. And I'm completely confused on everything else that happens.
That's a big jump that went here.
Yeah.
But the subtracting 1 dividing by negative 2, good.
So that's good. I just understand how we get what x equals from sine x.
Yeah. So ultimately what we're doing mathematically, Alec, is we're taking sine inverse of both sides. That's technically what we're doing to try to get x alone. And so we would take sine inverse of 1/2. Only sine inverse undoes sine. So mathematically, now we have x alone, but then we're left with this question of basically, when does sine equal 1/2?
Okay.
So we're having to go into the unit circle, and instead of having angles getting ratios, we're having ratios needing to get back to angles. Now, careful, sine inverse says, I'm only going to give you 1 in your calculator. But when they tell me an interval, I have to use that fundamental, basic, or I think it's called principal value. I have to use the one that calculator would give me, which is technically 30 degrees or pi over 6, to think outside or broader and say, but wait a minute, I'm rotating more than just that one little basic piece. I have to think bigger. And so I said, well, thinking bigger is going negative pi, looking for anything there, and going 2 pi, looking for anything there. Pi over 6 is there, so he was an answer, because that's when sine is 1/2. But also in the second quadrant, sine is also going to be positive all these values again. So 5 pi over 6 also had to be.
Okay.
Is that cool?
Yeah, I get it.
Nice. And good verbalizing of the question. How are we doing? Are we using our new formulas to do like 5-1 stuff, 5-2 stuff, 5-3 stuff? You see it? We just expanded what we're capable of doing.
Let's call it a day.
So what does that mean?
Call it.
What technically are you able to do tonight?
Homework.
Except the whole thing. But do you have to submit it in Google Classroom tomorrow morning? No, because it's not technically due until. So what is the point of me giving you an extra day? Go, try, get stuck, push a little further, come with questions tomorrow. Finish, turn in on Friday. Is that cool? But remember, you want to finish, because did you guys see we only get a day and a half on 5-5? Because halfway through tomorrow, after I answer a few homework questions, we're going to go see the new formulas that hopefully you already have written down. And then use the new formulas. Now guys, hold on. Could we waste, there are some that are tricky in homework, I'm just ready for them. Could we waste a lot of class time tomorrow having you guys just write down formulas? Did you see yesterday how many seed in formulas? 1, 2 boxes, 3 boxes, 4 boxes, 5 boxes. Could we write down all these formulas in our notes? I guess. But wouldn't it be nicer if you already had them written down on a big, these are all the formulas from chapter 5, to where we didn't have to write them down. You have them in front of you. Let's just learn how to use them. Is that cool? Okay. So here's what my goal is for you guys tonight in homework. And yeah, Jaden, stop it. My goal for you guys tonight in homework is the following. Try what you can. Now, hold on. What you can do perfectly, or just what you can try? Try, no, don't go for perfection. Just go as far as you can, and I'm just asking you, internally, in your mind, in your heart, and your soul, go a little bit further, okay? Try what you can, but then make chapter 5 formula sheet. Why? So I'm going to grade it? No. Might give you bonus. But it's mostly for you guys to be able to study and for you to already have all the formulas written out, because to be frank, you don't need to memorize all of them, and if you have them all in front of you tomorrow, you're going to need to maybe use all of them in problems, and I can have you start and highlight the ones to memorize for the quiz. Does that sound good?
First, could you instead do like a flashcard?
You totally can do flashcards. I don't mind that. It just would be nice if you could have it in some way that you could kind of like be looking at all of them if you're given a tricky problem. Does that make sense? But yeah, I don't know. But I would have them all written out tomorrow, because to be frank, I don't want you guys to waste time. The section 5.5 formulas are very specialized. Does that mean that they're not important? No, there are some that are super important for future math, as far as like being able to recall, and I'm having you memorize those, but some of them are just useful. And it's one of those things that you could always look up and use if you ever needed it. I just want you to have it written so you can use them in our problems. To that end, we have what, like 2-3 minutes? I'm cool just letting you guys, well, here, I'm going to throw up, put on the screen, 2 of the ones that kids ask every single year from homework tonight that you guys are going to be trying. 3, actually. So if there's anything that you guys want to ponder or think about or talk about, you can, but you can also just check in with each other, say hi, say happy Wednesday. Thank goodness it's Wednesday, not Tuesday. We didn't have school on Monday.
Thank goodness it's Wednesday.
I agree.
My group is gone.
And have a quick little detox before period 5. We just have period 5.
Spanish.
Wow.
Spanish.
That is
I
last
don't
year.
Lady.
That's nice. As kids are detoxing, don't these look like examples for them? Going backwards, I'm number 36. People using triangles. Using formulas. You guys got this. Any questions? Alright, guys. Get out of here. You're fine. Someone let someone out early. I don't know who or what or why, but you guys can join them. May as well. Won't be my fault.